Hi, my name is Hannah Welburn, and today I'm going to be talking about the golden ratio. The golden ratio is basically one of the great wonders of the natural world and is the ideal number that is a measurement of perfection. The mathematics of the world's beauty brings pleasure to the eye and allows man and beast alike to marvel at the splendor that is in the world around them. The golden ratio's value is 1.618033988749895, and so on. What we're going to be talking about today is we're going to take a look at the number behind this great wonder of the natural world, which is the 1.6 and continued. The golden ratio even applies to human faces, which can be a good or bad thing. The world isn't perfect, and flaws in the ideal number can cause negativity for those afflicted with it. These flaws oftentimes are a sign of health issues and can lead to very serious problems. It's rather common for someone's dimensions not to line up with the standard of perfection we find attractive, which can harm your view of others and their first impression of you as well. Although some deem the golden ratio a myth, I find it to be the driving force behind much of our world's workings and necessary to survival. So, this is a demonstration of how the golden ratio is found. Basically, you take line segments, and the line B right here would basically be explained by the golden ratio's proportions can be represented by 3 line segments. The golden ratio values exist when one line, we'll call it A right there, is 1.618 and so on times greater than another line B. Then line B is then 1.6 ... times longer than C. This is much like pi, although it is not to be confused with pi, and the Greek value for the golden ratio is actually phi. So it's a little bit confusing to people sometimes, but it does have an explanation, unlike pi, which just doesn't really make sense to most people. So here are some examples of the golden ratio. The sunflower demonstrates the Fibonacci spiral, which Fibonacci uses the same value as the golden ratio, and when it's diagrammed out, the sunflower actually is a perfect example of the golden ratio in nature. Then there's also in the face, which Angelina Jolie, to this point, has the most accurate facial structure to meet the golden ratio that we have found in human history. Basically, the way that you can measure the face is you can see all of these focal points on her face have a line drawn between them, and they all correspond to other lines in the face and meet the 1.6 and so on ratio. A couple of the common measurements for the face would be length of face versus the width of the face, the distance between the lips and where the eyebrows meet versus the length of the nose, and the length of the face versus the distance between the tip of the jaw and where the eyebrows meet, the length of the mouth versus the width of the nose, and then the width of the nose versus the distance between the nostrils. Then there's also the distance between the pupils versus the distance between the eyebrows. I found that from a study done by Murali. Then there's also other common examples, which would be the teeth, and in the mouth there's all different types of golden ratio examples. There's the certain teeth versus other teeth in the mouth, and they're usually about 1.6 in a ratio in a perfect mouth. And there's a ratio between the height and width of each tooth individually. And the golden ratio is vital to healthy teeth. If you need dental work, that's because your mouth does not fit the golden ratio measurements. And that's why so many of us need braces, because the world isn't perfect. Then we have the 4 fingers on the hand, which doesn't include the thumb because the thumb is weird. And the top 2 segments of each finger in comparison to the length of the entire finger measures out to be 1.618 ... And the relationship between the middle finger and the pinky is also the 1.6 ratio. Then there's the lungs, and since one lung is larger than the other, the bronchial tubes in each lung is a different size, and the larger lung has a longer bronchial tube, and it is 1.6 times longer than the shorter lung, at least in the perfect world. And again, if you don't have that, then that can cause breathing troubles, and that's one of the main reasons that we have for breathing problems. A couple more examples are DNA molecules. The size of the molecule width versus the height is 1.6 ratio. The inner ear, the cochlear tube, much like the sunflower, is an example of the Fibonacci spiral. And also the heartbeat. The blood pressure as it goes through the heart, when it pumps in, is a certain pressure against the vein, and as it pumps out, it's another pressure, and that is a ratio of 1.6. Then here are a couple more of the negative effects of not meeting the golden ratio standards. There are certain facial structures that are proven to be more prone to particular medical issues. And for example, longer faces tend to have respiratory diseases, and shorter faces tend to have abnormal jaws, which affects overbites, teeth placement, etc., which again is why you would need braces or other medical work done. A large majority of structural diseases are due to the improper proportions of the human body that are not in line with the golden ratio. So much like the spine, if you have back problems, it's probably because your spine is out of line with the golden ratio. Then there are a couple of experiments that support this theory. The classical and Renaissance sculptures experiment, the independent variable is the height of the statue compared to the golden ratio, and the dependent variable is hemispheres that light up when viewing the different statues in the human brain. These are the different statues that they used. The center one is the one that meets the golden ratio dimensions, and this one is a little bit longer, and that one's a little bit shorter. And they didn't ask people questions while they were doing this necessarily. They also were monitoring the pictures in their brain and what was lighting up according to what they were viewing. So here's an example of that. And basically I just took a quote from their findings and studies in their journal, and it says, the most striking result was that the observation of original sculptures relative to the modified ones produced activation of the right insula as well as some lateral and medial cortical areas, lateral occipital gyrus, precuneus, and prefrontal areas. The activation of the insula was particularly strong during the observation condition. Most interestingly, when volunteers were required to give an overt aesthetic judgment, the images judged as beautiful selectively activated the right amygdala relative to those judged as ugly. We conclude that in observers naive to art criticism, the sense of beauty is mediated by two non-mutually exclusive processes, one based on a joint activation of sets of cortical neurons triggered by parameters intrinsic to the stimuli and this insula objective beauty, the other based on the activation of the amygdala driven by one's own emotional experiences. So basically it was just looking at the hemispheres that would light up while they were emotionally viewing it, and the ones that would light up while they were viewing it in a more rational sense. And here are my sources, and that is all for the golden ratio.